Hello students, welcome to one more problem of System Verilog series. In this question, we will be solving a question based on fork join concept. So let's get started. So here in the problem, let's understand the problem statement. You are building a driver task. It needs to send a reset pulse and send a stimulus packet. In that order, both must finish before the driver moves on. There's also a background watchdog that should start at the same time and keep ticking even after the driver is done. And we are also given some of the conditions here, like send reset is one of the tasks that you are given. Finishes at time t equals to 10 seconds. Send stimulus finishes at time t equals to 30 seconds. Driver done time. This is, I think, a time that is you guys are given in the problem statement, which should get printed at around the time that it should display should be 30. And two more statements we are given is the watchdog should start from time t equals to 0 nanosecond and should be still running even after the run task. So the watchdog timer should start at the beginning and should continue even after your code finishes. And you're not supposed to use any delays in the code. So this problem looks simple. So let's get started with the solution of the problem. So here, if you see in the right hand side of the screen, you're already given the signal names and the task predefined. You just need to call this task in such a way that all the conditions in the problem are met. So, for an example, let's say there are already three tasks given: send, reset, send, stimulus, and watchdog. And let's say here you just need to call this task. Let's say, okay, so let's start writing the code. First, 2 points that we are given in the problem is send reset should finish at time t equals to 10 and send stimulus should be finishing at time t equals to 30. And if you see in the task predefined in the code, you're already given this delay 10 and 30. So you're like, we can just declare this, we can just call this task as well here. And when you call this task, this time will definitely be 10 because it will this reset done time would only be printed after 10 seconds. And then here you are also supposed to call the send stimulus. And one thing that you need to make sure is this both should happen in parallel. So here, when you use fork join, so this both tasks could be executing in parallel. That is, the send reset would and the send stimulus will eventually get started at time t equals to 0. The reset done time would be 10 and the stimulus done time would be 30 as soon as this code finishes, and which also satisfies the first 2 points. Now we are given one more point that the driver done time should be 30. So here if you see the driver done time, so the fork join is used, so the code will only come out of fork join as soon as this both tasks are completed. So the send stimulus takes more time to complete. So once this task is completed, then only the code will come out, and then it will print this time driver done time, which eventually will be 30. So with that, our all the three statements are satisfied. And we have one more condition that the watchdog should start from 0, time t equals to 0 in a second, and should be still running even after the run task. What does that mean is the watchdog should also be started at time t equals to 0. So let's call this task as well. Let's call this watchdog task. Right. So here now this would start at time t equals to 0, and it should still running even after the run task is completed. So here the problem is, let's say if you define this watchdog inside the fork join, then the join would eventually only come out of this fork join as soon as the watchdog task gets completed. But if you see inside the watchdog task, what we are doing is we are iterating through the delay of 1 nanosecond for 500 cycles. And so this task would only be completed once you have 500 after 500 nanoseconds. So it would take around 500 nanoseconds to come out of this task, which means that your fork join would eventually get completed after 500 nanoseconds. But then if you see the value of driver done time, then it would be 500, not 30. So in that case, your condition 3 would be false. So this approach is definitely incorrect. We need to find some better way to solve this. So instead of defining this task here, I would just define this task at the top, and I would just add one more fork join here. Let's say begin and end. Let's say begin and end. So also note that if you don't write begin and end inside fork join, then each line is treated as a different thread. So here this is treated as two different threads. If you write for begin and end, then the begin and end itself would treat as a one single thread. So here, because we have explicitly mentioned begin and end, so this is our thread 1, T1 I would say, and this is your thread 2. So here, and we also need to do complete the fork. So you can just, all right. So here, if you see, this is our thread 1, and this is your thread 2, this complete. And inside your thread 2, you also have one more fork join inside it. So the way of ex and here you would be not writing join, instead you would be writing join any. So how it would, so the way that it will execute it, let's say the task run is called, and first it would start with watchdog, so this would be called. So it is now running with parallel to this thread, send reset and send stimuli. So this task fork join, this will only come out once this is completed. So let's say if this, so once 26 to 31 line is executed, this T2 thread is completed. That is from 24 to 32 line, from here to here. As a result, 34 line gets also unblocked because it's fork join any. So if any one of the thread is completed, then this would be unblocked, and you would be here printing the value of driver done time is 30, which eventually satisfies this condition. And our fourth condition is also satisfied, that is watchdog should start at 0 and it should run in parallel even after the code gets completed. And we haven't used any delays for this, so let's try simulating the code. Alright, it seems that our all the test cases passed, which means that the code that we have written is correct. That's all for this problem. Thanks for watching.